So here we are at the last topic with our systems mini unit, so to say. And that's actually taking what we've been doing and using it to solve real world problems. So today, our word problems. We're not going to actually solve and find the answer. We're just going to go through the setup. If you would like to solve to practice your methods, that would be a great idea. So let's go through. Remember, we have a rule of 3 when we're doing word problems. We read it 3 times. So one number added to 3 times another number is 24. 5 times the first number added to 3 times the other number is 36. Find the numbers. Okay, let's go back through now. One number added to 3 times another number is 24. So we know we have one number and we're adding it to another number. Those are 2 different numbers right now. We don't know what they are. So that's 2 different unknowns. Then it says 5 times the first number added to 3 times the other number. Find my numbers. So we're looking for numbers that when we do get the actual answer, they will add 3 times one of them added to the other is 24. 5 times one of them and 3 times the other is 36. So when we have these system word problems, the very first step is always to identify your variables. You will be doing systems of equations whenever there are 2 unknowns. So write this down, please. When there are 2 unknowns, and I have to find both, it's a system of equations. So let's go look now. Well, I'm going to let x equal my first number. And then I'm going to let y equal my second. So x is one of them. Y is the other. Your second step is to write your equations. Now you're going to have to go back into the problem and pull out some facts. It says one number added to 3 times the other is 24. You might need to write in the word is means equals. But it says one number, so that's our first number, added to, so x plus 3 times the other is 24. So now I have to go through, there is going to be another scenario. I have 5 times the first. Well, what was my first number? X, so it's 5 times x. Added to, so plus 3 times the other. Well, what was the other one? Y. And then it says is 36, so equals 36. What a lot of us do is we just read it so fast, oh my God, I can't do it. Stop. Once you define your variables and break it down, you can do this. So then our final step in all of this is to solve by substitution or elimination. You could use either method here. Again, we're not going to solve them in the video. You're going to do that if you'd like to for practice. Okay, let's read this one. Ashley had a summer lemonade stand where she'd sold small cups of lemonade for $1.25 and large cups for $2.50. If Ashley sold a total of 155 cups for $265, how many cups did she sell? So we got to go back through. Ashley had a summer lemonade stand. Okay, not really important. She sold small cups and large cups. Right there, if we define our variable, I'm going to let S equal the number of small cups. Because remember, that's what we're looking for. We're looking for how many of each. So S is the number of small, and L, and I kind of did a slanted L, is the number of large. And it's the number of those sold. It's not their price. We already have their price. So now I have to write my equations. So if I look at the first one, it says she sold a total of 155. So that means if I just take S plus L, it should equal 155. That was the total number of cups. Okay. But then she sold the small for $1.25. So she would make $1.25 for every small cup sold. She sold the large for $2.50. So then she'd make $2.50 for each large. Now, how much money did she make total after selling all these cups? She made $2.65. Finally, what would our third step be? Solve by substitution or elimination. And yes, we want you writing every single one of these steps. The more you write them, the better and easier this will become. We also want you to highlight in the word problem just the way we've done it here on every single one. All right, so now that we're hopefully getting a rhythm here, let's go look at our next one. Your family goes to a Southern-style restaurant for dinner. There are 6 people in your family. Some order the chicken dinner for $14, and some order the steak dinner for $17. If the total bill was $99, how many people ordered each dinner? Well, let's go look at this. There was a chicken dinner and a steak dinner. So some ordered chicken, some ordered steak. So let's define our variables, because we're looking for how many ordered each one. So I can say let C equal the number of chicken meals, and let S equal the number of steak meals, because we're looking for how many of each. So now we need to write our equations. Let's go back into our word problem. There's 6 people total. That is our total. So if I take the number of chicken and the number of steaks, it should total 6. So number of chickens plus number of steaks, total 6. Then let's go look for the next equation. Chicken dinners were 14 each. There are 14 per meal. Well, C was the number of chickens, so 14C. But I also have to total my bill and add whatever steak dinners, which were 17 each. And my total bill was $99. Okay, so that should total 99. Finally, step 3 would be to solve by substitution or elimination. So take a look at these two. Everything has, for the most part, a similar setup when we're doing systems of equations. We want you to try these two on your own. All we want you to do is come up with the 2 equations and define your variables. You do not have to solve them, okay? But somewhere on your paper, you need to have written down that when there are 2 unknowns, I need 2 equations in order to find them.